Hello class, Kaiwan here. So today I'm going to share with you on how I draw a projection frustum or a projection beam angle in 3D in Vectorworks. Alright, so let's get started. First thing first, you'll probably wonder why we draft in 3D in the first place. To explain that, I have this very simple example to show you why it is important and very helpful for a projection designer to draft in 3D. So here we have I have a projector that's projecting on those 1, 2, 3 panels that if you look from the right point of view, from the side, like you can see that those are actually 3 vertical rectangular panels, and my projector is pointing down, like it's tilted down and projecting on them, right? So looking from the side, this looks fine, right? Like everything is within the projection coverage. And if we look from the top, it probably seems at the first glance that we're fine as well, right? Everything is within our coverage. But if you go into 3D, and to do that, I'm gonna use click OK. If you see in 3D, and if you actually render, it would be easier if we render that in OpenGL. You can see that we have a problem here, right? So the outer corner, the top corners here are not being covered. And that makes sense because the projector is tilting down, so the width of the image at the top is narrower than the bottom simply because they're closer to my lens, right? And you can probably tell that by looking from the top, because those two lines here, the inner two lines, are representing the edge, the top edge of my frustum, but that's not very intuitive, right? And it's very easy for me to miss that by looking in 2D. But it's so much more intuitive, right? And by the way, I'm holding down Control and my middle mouse button to that's the shortcut to activate the flyover tool. And if you hold down Control Shift G, that's the shortcut to render in OpenGL, right? If I look in 3D, that is very intuitive and very instant for me to discover the problem, right? And that's why it's very helpful for us to draw in 3D. So now you know why, and let's get started on how to draw a 3D projection frustum. So to do that, before we draw the actual frustum, there is some setup work we need to do. So the first thing we want to match the layer scale that we're going to be working on, and that's going to be that's going to be decided by the document that you're drafting onto, right? So if you're drafting onto a technical drawing, oftentimes that's going to be in 1/4 inch, right? So we're going to pick 1/4 inch and click OK. So everything on this layer is going to be in 1/4 inch. And by the way, if this border that shows the size of the paper bothers you, you can always go to File, go to Page Setup, and uncheck here, Show Page Boundary. And you can also tell Vectorworks not to show watermarks or page break as well. So you have a way more cleaner, I guess, space to work with, right? And that's the first thing you want to do. And the second thing is that because this, you probably aren't going to work on a blank document like this. You probably are going to be work on a document like this, right? Where you have the technical drawing of the theater and you already have all the classes that this document comes with, and you don't really want to touch that, right? You want to keep all your drafting on different layer so that you leave everything else untouched, and you can always gray them out to make your thing pop, to make the projection pop up, so it's easier to for everybody else to see, right? So you want to put everything projection-wise on a separate design layer, and also have its own class, right? So to do that, Let's go back to our original drawing. Let's create our new own design layer. Let's call that projection, right? Click OK. So now everything's going to be on, we draw is going to be on the projection design layer, right? And actually, let me just do that on the technical drawing of Brockett, so it's easier. So we have a clear context to help us understand more, right? So let's just draw over that. So I'm gonna create my own design layer, call that projection, right? And I'm going to create my own class as well, right? And by the way, in Vectorworks, if you want to create the subclass like these, the way to do it is that you put the name of the master class you want and add a dash and put the name of the subclass. So in this case, I want everything projection-wise under this class, master class called projection, and I'm going to create this subclass called 3D Frustum, right? Because I probably want something else under the projection class as well. Maybe I'm going to have a class of projectors. I'm going to have a class of, all my system diagram drawings as well. So, right? So in this case, I'm going to create a subclass called 3D Frustum and click OK. So now, and I'm going to make that class active, right? So now everything I draw is going to be under this 3D Frustum class. So now we have everything set up, and we can start to work to draw the 3D Frustum. So to draw any frustum, we need some information, right? We need to know that what lens and what basically we need to know two information, right? We need to know the lens ratio. Let me make this bigger so it's easier for you to see. We need to know the lens ratio, and we need to know the aspect ratio. Aspect ratio, right? Because those two information is going to define the shape of our frustum, right? So, and eventually you're gonna, like when you're working and figuring out your projection drafting, you're gonna make those decisions. You're gonna pick, say, where I'm gonna start by maybe trying a 0.8 fixed lens. Let's go wide angle lens, right? I'm gonna start with this lens, and I know that the projector I pick have 16:10 aspect ratio. So I'm gonna start with that and see whether this setup will work for my for whatever I want to do, right? If this doesn't work, I'm gonna pick a different lens or maybe a different projector, right? But for now, let's use this setup as example to draw our frustum, right? So let's move this to the top, and so we're gonna start with 2D, right? Actually, let me clarify that. Over 1, yeah, that's gonna be my lens ratio, right? So we're gonna start with 2D, and if you remember the lens ratio, that's the width. Actually, the distance from the center of your lens to the center of your image, projected image, and that's also called throw distance, over the width of the projected image, right? So if we have a 0.8 over 1 fixed lens, that means that if my width of the image is 10 feet, I'm gonna get that size of an image with the 10 feet widthwise if my projector is 8 feet away from that picture, right? Or in other words, if my projector is hitting on a surface that's 8 feet away, the image I'm gonna get is gonna have a 10 feet width, right? So this T shape is gonna define our 2D Frustum, right? Actually, I can already draw the top view of my frustum, right? So that's going to be the width of my image, and this is my center line, and that's going to be the beam, the edge of my beam, right? So now we have the top view. We're gonna figure out this how does this frustum look like from the side, right? So that's when the aspect ratio comes in to help us decide the height of this image, right? So to do that, I know that my aspect ratio is 16:10, so I'm gonna just draw a rectangle. And by the way, I'm doing that by selecting the rectangle tool here, or you can just hit 4 and just drag. And I'm gonna hit tab to activate the floating window here that allows me to manually type in the size I want, right? In this case, I'm gonna start with the 16:10 feet rectangle, right? And you can see that that's too big to fit our image because this width is 10 feet and this width is 16. So I want to make that smaller, right? So I can just match the corner here and rescale that. And I'm gonna create a smart point by hitting T over this point, and I'm holding down Shift so I can rescale that proportionally. And I'm gonna snap to this point. So now I have the width of my square being 10 feet, right? By the way, you can also do that. Let me go back. You can achieve the same results by selecting this object, whatever the object you want to rescale, and go to Modify, Scale Objects, pick Symmetric by Distance, right? And you pick the current distance. That's going to be a reference for you to decide from which size I want my original object to be scaled to, right? So in this case, I'm picking the width of my rectangle as the reference. I'm going to say that take this rectangle that's with the defined distance, in this case the width, that's originally 16 feet, and make that into 10 feet, right? And click OK. And you can see now the width of my rectangle is 10 feet. Right? So that's the same thing. And now we can align this rectangle with our top frustum, right? But that's not what we want. We want this because this is looking from the top, and we want it to, this is the height, but we want the height to actually be there from looking from the side. So I want actually to rotate this 90 degrees from the side, right? If I go to the right view and hold on a second, let me move this to somewhere that we can easily see, right? Here's fine. And now if I go to this, if I select my rectangle, go to right, and you can see that right now it's lying on the ground, but we want it to be vertical, right? So to do that, I can hold down Control L. That's the shortcut to rotate anything clockwise, I believe, 90 degrees, right? So now I can match the center of my image square to the end of my top frustum, right? So now you can see that we already have a skeleton of a 3D frustum, right? And now all we need to do is just connecting all the four corners to the origin of my lens, which is this point right here, right? And we have a 3D frustum. So to do that, we actually need to use the 3D polygon tool, because 2D polygon can only draw on the plane that's either from the top or from the side, or basically any plane that's aligned with either X, or I guess X, Y, or Z plane, right? Any more custom defined plane, the 2D polygon will not do. Actually, you can see if I try to draw anything, that it's not going to work, right? It snaps to the X plane in this case, right? So we need to use 3D polygon tool, and that's going to be under the tool set, the 3D modeling tab, and you can find the 3D polygon tool here. Click to activate it, and we can just draw over those points, and voila, we have a 3D polygon, right? And we can keep doing that for all 4 sides of our frustum. I have 3, and I need the bottom as well. And now you can't really see because I'm in wireframe, but if I go into OpenGL, and you can see that I have the side 4 sides of my frustum, right? And basically, to this point, you already have something that you can start to work with already. That is already a 3D frustum, right? But there's still a few things we can do to make this thing way more easier to work with. And actually, if you look at the example I showed you a moment ago, right? That you can see that all my sides are actually transparent or translucent. That allows me to see that anything that's inside my frustum, so I can tell that what's being hit and what is not being hit, and I can still see everything that's inside of my frustum, right? And also you can see that I have this dotted center line that helps me to figure out where is the center line of my frustum, and I also have this these 2 actually hatched plane. One is here, right? And another one here, right? Those 2 plane that defines the center, I guess, plane, vertical and horizontal center plane of my frustum. You don't really need to do that, but I found it helpful because when I go into 2D, I already have something there for me to see the coverage of my frustum, right? And so let's and also you can see that this whole thing, this whole cone right now, this whole frustum right now is one thing, and then you can see it's a group. So that's very handy because we can just move everything all together, right? So let's make these happen. Oh, actually, it's this file. Ooh, go away, right? So let's make those changes. So first thing we need to do, let's draw the 2D, the horizontal, I guess, the horizontal and the vertical center plane, and also the center dashed line first, right? So to do that, let's go into the top view. And if you remember, when we were trying to figure out the skeleton of the 2D frustum, we already have the center line here that we can just select it and make it a dashed line. Oops. Here, right? And I'm just gonna pick one. Say this looks fine. So we already have the centered line. And let's draw the 2 center plane as well. So because we are working, our frustum right now is not rotated in any way, which means that our vertical plane is sitting on the X plane, and our I guess the horizontal plane, center plane, is sitting on the X plane of our document, and our vertical center plane is sitting on the Y, I guess, Y plane of our document. So we don't need to use 3D polygon tool. We can just use the 2D polygon and just draw over our frustum, right? So now we have this shape. Let's give it a pattern, give that hatch, and I'm gonna make it blue color, and I'm gonna make it transparent, translucent, 50%, right? And I'm gonna go into 3D and check. Now it's in place, and I'm gonna do the vertical center plane as well. So 2D polygon, and just draw over it, and give it the same pattern, right? Where's that blue I picked earlier? This. And I'm gonna give it 50% transparency as well. And in this case, we're gonna move it in place. Hold on. Let's go to the top view and move it in place, right? So if we check in 3D, we have the center plane of the horizontal plane and the center plane of the center vertical plane in place, and they're transparent, which is good. So we can see through everything, right? But we still have those 3D polygon here that's solid, and when we render them out, we can't really see anything inside of it, and that's not good, right? So we want to make those transparent as well. However, in Vectorworks, you can see that I don't have an option in my attribute to allow me to set these transparent because they're 3D polygon. So the way to do that in Vectorworks is that you actually need to create a texture, and that with transparency, and you have to apply the texture onto those 3D polygons. So let's do that. So to create a renderwork texture, you go into your resource manager and select the file you're working on, and right click on it and choose new resource in your current file and choose renderwork texture. So I want to create a texture that has the same color as the blue I have right now, and I wanted to give it some transparency, right? So in my case, I'm going to call it, because I already know that I want it to be 80% transparent and I want it to be blue. So I'm going to call it 80% blue. You can call this however you want, that makes sense to you, right? But this is how I call it. And I'm going to give a color, click edit, and I'm going to give it the same blue I have. Click OK. You can see in our preview window that our texture has the same blue already. But to give it a transparency, we're going to go under transparency and choose glass. And you can see already that by the moment I pick glass, it becomes so transparent, right? And if I click into edit, you can see that the transmission percentage here is by default set to 95, which might be too much in our case. So I'm going to set it to 80 and click OK. And click OK. So now you can see that in your resource manager that you have this texture that's ready to go. So to apply this texture onto our model, I'm just going to drag it and over, and whenever you see this, and it's going to highlight whatever shape, whatever the objects, the 3D objects is you're going to apply onto, right? So I'm going to drop it into this 3D polygon. You can see that instantly becomes transparent, right? So I'm going to do that with the rest of my 3D polygon. And we have a transparent 3D projection Frustum ready to go. So, and there are still a few things we can do to make this easier to work with, right? One thing is that we can make this into a group by just select everything and hit Control G to make them into a group, and we can move them around as one thing, right? But there's one more thing that we can do to make our life easier, and that is to make it a symbol that can be stored in our resource manager, that can be reused over and over again, so we don't have to draw every time, so we don't have to redraw this 3D Frustum every time we do a new drafting. So as you can see here, I have this document open that I name it projection drafting resource. That's where I keep all my things, all my resource that all my beam angles drawn here, that's ready for me to import into whatever drawings I have, right? So that can help me to do my drawing very quickly, right? And I have all the informations here. So and every time when I want to import them, I just have this document open, and I have my drafting document open, and I can go to Resource Manager, pick my I guess drafting resource document, right? And you can see that I already put them in separate folders. I go to Beam 1610, and that's all my beam angle, and I can just pick one, the one I need, and just import them, right? And they're ready to go, right? So let's do that. So the way to do that is that we want to make them a symbol that can be stored in our resource manager, right? So the way to do that is that, let me ungroup this first. The way to do that, the way to make a symbol that we can reuse, right, is to select all the things we have and go into Modify and pick Create Symbol. So a symbol in Vectorworks is something that you can be reused over and over again, and you can create them in different ways. You can create them, you can either make that, I guess, a symbol that basically means that every time you import any symbol from the resource manager into your document, that's going to create an instance of that symbol that's going to point at the original symbol that you have, which means that if you change this original symbol, all the change is going to be automatically applied to all your instance. And that also means that you have very limited things you can change for your instance, because you don't want, because that's an instance to your symbol, right? So, and in our case, that's not something that you want to do, and I'm going to explain why. So instead, what we want to still use create symbol function, but we're going to store this in the resource manager as a group, right? You're gonna know you're gonna know why we want to do that in a moment. But for now, let's create the symbol, and we know that this is a Frustum that's for 0.8 over 1 lens, and it has aspect ratio of 16:10. So we're gonna name that with those information. I'm gonna pick insertion point. That's basically, where is the point I'm gonna pick for me to use every time I want to insert this symbol into my drawing. So I want to make that next mouse click, which basically means that every time when I import that symbol, it's going to allow me to import anywhere I clicked my mouse, as opposed to put that at the center of my drawing, right? I'm going to leave the unit as world-based to keep everything unit-wise consistent, and I'm going to uncheck the story aware and insert in the walls. That's something that you probably want to do when you want to create like a window for your architecture, but in our case we want to leave those unchecked, right? And here is the things that you want to pay attention to. We're gonna leave the instance in place so that when we make that into a symbol, we still have this in place, right? And we want to uncheck, change 2D objects from layer plane to screen plane. In our case, we do have some 2D objects, right? If you remember, we have the 2D polygons for our two center planes, and we have the 2D center lines, right? If we want to keep that in place when we go into the 3D world, right? When we like fly over it, we want to keep that in whatever plane you have, keep that where you are in the world, and because they are on a layer plane, right? And if I change them to screen plane, you can see that if I go into I guess not here, but here, right? Let me move the resource manager out of the way. If I change the plane to screen plane, you can see that it ignores the 3D orientation and it's always going to pointing at my screen, right? Which is not something we want, so we're going to make it back to the layer plane, right? So we want to do that. We want to do the same thing when we create symbols to uncheck that. So we want every 2D object to still stay on the layer plane, so they're going to stay in place, right? And a very important thing is that we want to convert them to group, because if you uncheck that, it's going to create a symbol. Actually, I'm going to show you the difference between that in a moment. So right now, I'm going to convert that to group, and under assign to class, I can pick that every time when I insert this symbol, it's going to automatically either look for this class or create this class to put this symbol under, right? So that's very handy to keep everything, all my things, under the correct class I want, right? So I'm going to click OK. And my mouse turned into this cross that allow me to define the insertion point of this symbol. So in this case, I'm gonna pick where the lens is, and it's gonna ask me where under this file I want to place this symbol, right? I'm gonna create a new folder and call that 3D projection Frustum and click OK. I'm going to put all my 3D Frustum under this folder, right? And click OK. And now you can see that I have this 3D projection Frustum folder here. I have this, why is it still called symbol 1? Oh, it's because we didn't rename it. I'm going to edit it and just pick symbol option. How do I rename it? Oh, I guess rename, and I'm gonna call it 0.8 1 over 1 16 over 10. I'm gonna rename that as with the correct information, right? So as you can see right now, it says, if I hover over it, it says type 3D group, right? And if I do the same thing again, leave everything else unchanged, I'm gonna give it the same name, 16 over 10, but I'm gonna name it symbol so you can tell the difference. I'm gonna leave the rest of the thing untouched, but I'm gonna uncheck convert to group and click OK. I'm gonna pick the same insertion point, put them in the same folder. You can see that right now I have this. If I hover my mouse over, it's going to say 3D symbol. So what's the difference between a 3D group and 3D symbol, right? So let me show you. So let me move this out of the way. So let's import them into our drawing. So that's going to be our 3D symbol. You can tell there's a 3D symbol here. And by the way, I'm doing that just by double clicking, right? So on the right, I have the 3D, I have this as a group, right? So what's the difference? The difference is that because we draw our frustum in this sort of unit size, right? We draw everything with the width of 10 feet. But in reality, if we want to work with it in our drawing, because our set could be anything, right? And if we quickly create a set with, let's say that we're gonna make a very simple set. Our set designer in a class gonna make something way better than this, but bear with me. I'm gonna just make some 1 inch, right? I'm gonna just make some very quick set. Just gonna be those 3 panels, right? So let's say that that's the set I want to project on, right? And the width is not always going to be 10 feet, right? It's going to be whatever it is. So we want to rescale our frustum to fit the width or the size of our set, right? And that's the reason why you don't want to make your frustum an instance of your 3D symbol. Because the moment I want to rescale it, you can see that here it doesn't even give me the option to rescale that, right? By dragging the corners. And if I use the scale object and say that, you know, I want this 10 feet maybe to be 20 feet and click OK, you see then it doesn't change the size-wise, right? And the only way that I can rescale it is by using the scaling factor here. And if I choose symmetric and you know that I want to make it like 120% size of this original size, that's the only way I can rescale it. So I have to guesstimate every time I want to rescale that, right? And that's not very handy. But if with a group, I can rescale it just by doing this, right? And actually, oh, I guess maybe we missed this line when we create the group. Oh, hold on. What did I do here? Did I do something wrong? Oh, I guess you don't want to really do that because those individual objects have different axes or different pivot point, right? But I can resize my group by going to the scale objects and say that pick the current size as 10 feet, right? And I want my new distance to be the width of my set, right? And I'm going to click OK. And you can see that right now I have my frustum to have the same width of my set. And that's very handy, right? And you can only do that with group, not with the instance of a 3D symbol. So that's why when you create a symbol, you want to have this checked, convert to plugin objects, or I guess not objects because it's already a 3D symbol. To convert that, I guess I'm going to use this maybe as an example. You want to convert that to group, right? So that's the reason why. So right now we have this as a group, and it stays in our resource manager, so we can always reuse it, and we can just drop it in our drawing, and you know, rescale it however we want, move it into place, right? Like this, right? And I can say that I want to rotate it by holding on Alt and the equal mark. One more time, right? And I can rotate however we want. I've discovered that, the unit size of our frustum is too small. Maybe we want to rescale it. And here is maybe the case we want to do some guesstimate. I'm gonna say let's make it 150% bigger. Click OK, and I can shift it to anywhere that's close, right? And if we go into 3D view, there we go. That if I render in OpenGL, I can see that right now I'm not hitting the corner of those surfaces. So I probably, let me turn the walls off and render that in wireframe, right? So maybe I want to shift my projector further away, right? And this, you can see, is still a pretty unrealistic place maybe to put your projector. Since it's so low, you probably, if I turn on the catwalk class, you can see, right? So probably I want my projector to be somewhere here. So I want to make this way bigger. Let's say two times, and maybe put it somewhere here. Okay, right? And here you can tell that you maybe want to use a narrower lens because we're throwing away a lot of resolution, right? But you get the idea. And now we can see that definitely. Let me turn off the walls again and turn off the catwalk again so it's easier for us to see. And now definitely we're hitting everything, right? And that's it. That's how you make a 3D frustum in Vectorworks and use it in your projection drafting. All right, thanks guys.